Hello, dear aspirants. This is Dr. Soros's classes. So we are now going to solve a question on what can I say? The question on complex analysis. Okay. So the question is telling us that let Z1, Z2 dot up to Zn belongs to C such that modulus of Zj equals to 1 for all j equals to 1 to up to n. Okay. Now, let us consider the function that our f from C to C defined as f of omega equals to omega minus z1 into omega minus z2 dot up to omega minus zn. Now, for all omega belongs to C. Now, we have to prove that the set of this where our modulus of omega is equals to 1 contains the interval closed 0 1. That means we have to prove that the closed 0 1 is a subset of this set. Okay. So let us understand the function first. Okay. So Z1, Z2 dot up to Zn belongs to C. Okay. And with our property is modulus of Zj is equals to 1 for all j. Okay. And our f of omega is looking like this. Okay. So we need to analyze our modulus of f omega for omega on the unit circle. Modulus of omega equals to 1. Now we are going to evaluate modulus of f omega. Okay. On the unit circle. So the unit circle, we know that that is equals to modulus of omega equal to 1. So we can also write the omega equals to our e to the power I theta for some theta belongs to close 0 to open 2 pi. So then our this thing will look like what? Modulus of f omega will equal to big product of j equal to 1 up to n. We should get modulus of omega minus zj. So now since our modulus of zj is equals to 1, we can write that our zj is equals to some e to the power alpha j, where our alpha j is lying between closed 0 to open 2 pi. Thus, we should write that the modulus of omega minus zj is equals to e to the power I theta minus e to the power I alpha j modulus, and that is equals to 2 of sine theta minus alpha j whole by 2. Okay, we easily know that. So now from this we can easily write that our modulus of f omega will be now 2 to the power n into the big product j equal to n, and that is modulus of sine theta minus alpha j by 2 Now after that what can we do? So now we are going to find the range of modulus of f omega on the unit circle. Now the maximum value. When omega is far from all zj, the modulus of f omega can be large. But since our modulus of omega is equals to 1 and zj is also modulus of zj is also equal to 1, the maximum value has to be finite. So however, we are interested in the range closed 0 1. Okay. So now from this thing what we can get? From this thing what we can get? We can get the maximum value will arise in this, and we got this thing, so that's why. Now the minimum value 0. So that will happen when, so if our omega will equal to zk for some k, then our modulus of f omega that is equals to 0, because our omega minus modulus of omega minus zk is equals to 0, thus 0 is achieved. Now the intermediate values, we need to show that for every y belongs to this close 0 1, there exists omega such that modulus of omega equals to 1, such that modulus of f omega equals to some y, equals to that y. So now the continuity argument. So consider the function. Let us consider a function such that g of theta equals to the modulus of e to the power or f of e to the power I theta. So this is a continuous function of theta, because we know that our f omega is a polynomial in omega, since hence continuous. The modulus function is also continuous and the composition of continuous functions is continuous. Since our g theta is continuous on the compact set closed 0 to closed 2 pi, by the intermediate value theorem, it attains all values between its minimum and maximum. So we already saw that our g theta equals to 0 when omega equals to zk, that is theta equals to alpha k for some k. Now we need to show that g theta attains the value 1 somewhere on the unit circle. Now the existence of omega with modulus of f omega equals to 1. Let us consider omega equals to minus zk for some k. Okay. So now that is, we can write it as omega equals to e to the power I alpha k plus pi. Okay. So then we can write that modulus of omega minus zk equals to minus zk minus zk, so that is equals to 2. For other factors, that means our omega minus modulus of omega minus zj, where our j is not equals to k, we should have what? We should have omega minus z, modulus of omega minus zj equals to minus zk minus zj less than equals to minus zk plus modulus of zj, that is equals to 2. Now, thus we can write it as modulus of f omega, that is equals to from j up to n omega minus zj, that is equals, that is greater than equals to 2 into the product of other factors However, this is not directly helpful. Instead, consider the average behavior. So, alternatively, consider the maximum modulus principle. So, from that, we can say that our modulus of f omega on mod omega less than equals to 1 occurs on the boundary modulus of omega equal to 1. Since our f of 0 is minus 1 to the power n, z1 z2 up to zn, and our modulus of f of 0 equals to 1, then the maximum of modulus of f omega on mod omega equals to 1 is at least 1. Thus there exists omega. Thus there exists omega such that mod omega equals to 1 and modulus of f omega less than equals to 1. But since our g theta is continuous, attains 0 at a value greater than equal to 1 by the intermediate value theorem, it attains all values close 0, 1. So from that we can easily say that our closed 0, 1 is the subset of yeah. So hope you understood, guys. Thank you.